and then you're not going to understand any of them. So I need you all to be comfortable with that then. We're going to go through the steps, and you're not going to understand any of them, and then we're going to practice it, and then the steps will kind of make sense. Okay? So just be emotionally prepared for me. I'm going to say a lot of stuff, and you guys are going to be like, nah. Okay, so if you guys remember what perfect squares are, there's a bunch of them on the back. What are the perfect squares? Right, it's up, right? The two factors. So we would say, you guys would agree with me that 36 is a perfect square, right? Because its two factors are exactly the same. There's 6 and 6. There's a few more factors in 36, but what makes 36 unique is that if I were to draw it as an area, you could have an actual square, right? A 6 by 6 square. Got me? Okay, so we can do the exact same thing using algebra and binomials. So when we talk about perfect squares in binomials, I know that x squared plus 4x plus 4 is a perfect square. Because if I go and factor that, what are the factors of this? 4 and 1 don't add up to 4. 2 and 2. So this would be x plus 2, x plus 2. So because the two factors are exactly the same, we would say that this trinomial is a perfect square. Does that make sense? Okay, and math, as mathematicians, we are efficient. We like to cut down on writing stuff. So we, instead of writing these two as separate things, we're just going to go x plus 2, and we're going to throw a little squared up there, because we're not going to write that twice. We don't have time for that. Homework. Okay, so we're going to be efficient and write it like this. Okay, can someone else give me an example of a perfect square trinomial? It's a trinomial. So I'm looking for this. Can somebody else give me an example of a perfect square? You're there. Because the factors of 36 are 6 and 6. We just went over that one. But when I add them together, what do I get? 12. So I know it would be x plus 6 and x plus 6. I wrote them up twice. This would be x plus 6 squared. Right? You guys got that? So you get the idea of what a perfect square is in trinomials. Like we get it when it's just numbers. Like that makes sense. We dealt with those a lot. But now we're dealing with them when we're in algebra. Okay. So the whole goal of this is we are going to go from standard form and we're going to put it into vertex. That's the whole goal of completing the square. Okay, so we're going to make it look like it's going to start as the pink and it's going to move to the green. All right? Nice thing about this is you get the benefit of seeing it in standard form, getting the information from that. Putting it in vertex form, you can get the information from that. All right, so if we have it in standard form, the first thing we're going to do is we're going to group the x's together. All right, we're going to remove the coefficient from the x squared. We're going to common factor, but I call it common factoring, but only what's in the bracket. So we're going to kind of twist. We're going to bend some rules here. We're going to take the coefficient of the x, and we're going to divide it by 2. We're going to square the quotient. Add this number inside the bracket and subtract from the outside of the bracket. Factor the perfect square and simplify the numbers outside the bracket. Now your equation's in vertex form. See, I do this stuff to make no sense. But I will tell you once we practice, it will get better. Okay. That was a lot of words. You guys ready to do this? Perfect. All right, so we have f of x is equal to x squared plus 6x plus 5. Okay, so the first thing I'll do is I'm going to group anything that has an x in it. And luckily, in standard form, they're written in order. So they should be side by side. Can you handle that? No? That was the hard part? Okay. If I had a coefficient here, I would common factor out the coefficient, but only the stuff in the brackets. So this is the bending of the rule. The bending of the rule. We'd be looking at this if there was a coefficient here. Don't worry, do you want to look at coefficient, but start easy. So this one doesn't have anything to common factor out. Okay. So now I want you to write it like I'm about to do. All right, I want you to leave yourself some space. There's going to be a big exciting reason for that. Okay, so the next step was what I call my side note. I don't know what am I on? Okay, so I'm on step 3. Okay, so this was step 1. Factoring out was step 2, but we don't have anything to factor out, so we didn't do step 2. Step 3, I like to do it off the side, and I label it, it's my side note, so I label it SN. That just means that it's not part of the equation, it's just a rough math I'm doing off on the side. So I'm just going to show you that, and you're going to get good at this. Okay, so you're going to take the coefficient on the x, which happens to be 6. We're going to divide it by 2. And then we're going to square the answer. So what's 6 divided by 2, everybody? 3. I'm so proud of you guys. So good at math. Love it. And 3 squared is? 9. Okay. All right, so we did step 3, and you guys are like, that makes no sense because you did. That's okay. So we said that we are going to add this inside the bracket. Oh, this is step 4, by the way, I think. And we are going to subtract it outside the bracket. Now, why did I add and subtract? Right, I'm not changing any values. I just added 0. All I want to do is keep it the same graph, the same everything. So I have to add 0 to it. Does that make sense? Positive 9 plus negative 9 gives me 0. I'm just changing the way it looks. Okay, all right, okay. Okay, step 5. Oh, notice my equal sign keeps carrying down from every line. Did you guys notice that? You must do that. Because if you drop the equal signs, then you just change it into an expression, and that will get you a half-mark deduction. I'm not so worried about rewriting the at the backs, but you're showing me that these lines are equivalent. Okay? That's one of those detailed things that we're going to do. Okay, so we are going to factor this. If we have done it right, it's going to be a perfect square. So what are the factors of 9 that add to 6? 3 and 3. Are you guys okay to jump right to here? Right, because that, I'm just going to go back up for a sec. That means the same thing, right? Are you guys okay just to jump to that point? Or do you want to write it out? You can tell me to write it out, it's fine. Okay, there's Cameron has an opinion, no one else does. Perfect, I love it. Okay, so now I have, that was step 5. That was step 5. And what's step 6? Okay. No, seriously, like, okay, so step 5 was factoring, I guess. So this would be x plus 3 times x plus 3 plus 5 minus 10. This is still step 5. So now, on the next line, I'm going to be efficient, and I'm not going to write x plus 3. I'm going to write it as x plus 3 squared. Ladies and gentlemen, if this is not a perfect square, you've done something incorrectly. Okay. And then I think step 6 says, okay, so I didn't finish step 5. Step 5, I need to simplify. So positive 5 minus 9. And step 6 is you're now in vertex. Okay. We're going to practice this, and I'm going to teach you some tips and tricks. Tips and tricks are always good, because sometimes we get bogged down with this, and I'm going to be honest with you. I very rarely convert to completing this way. I very rarely do this. I use my secret formula more. Because if it's in standard form and I use my secret formula, I can still find the vertex, right? And really, once I have my vertex, I can find how many zeros I have. But then some people, I've met a few students who say like, oh, this is so easy, I have no problem with this. On the other hand, doesn't come as naturally to me. We will use it in calculus if you choose to go that route, but you won't use it. You will use, I don't know, use what you like. Okay, you'll have to find the vertex, right? And sometimes you'll get it in vertex form. Most times you'll get it in standard form. Okay. All right, so this one has the coefficient. So, okay, so step 1. Look at me getting wild and crazy. I just grouped my axes on there. Okay, so step 1 is group my axes. That was step 1. Step 2 is going to be common factor out. Don't worry about the 16. Only worry about what's inside the brackets. So we're going to common factor out. And here, so this is the bending of the common factoring. You're going to take out only the coefficient. You're not, like, because I can take out an x here, right? Because, like, we were really common factoring, you take out the x. But this is the bending. I want you to take out that coefficient. So I'm going to take out the 3, but I'm going to leave the x squared minus 4x. I'm going to leave myself some space. What do you mean it's already a square thing inside? You need a constant. You need to have it as a trinomial, right? So we're missing that piece of the trinomial. Okay, here's the deal also with completing the square. This has to have a coefficient of 1. Must have a coefficient of 1 right there. So we're going to do some other ones. We're going to do things like 7/15. Okay, we're going to do some really ugly ones. And we're going to have to be okay with this. But I'm going to show you some tips and tricks to help you through the really ugly ones. Okay, so that was step 1, step 2. Step 3 is my side note. My side notes. What do I do with my side notes? And square the quotient. So -4 divided by 2 squared. So that's going to give me a -2 squared, which would be 4. So is it a +4 or a -4? +4. So it's going to be add 4. And if I, oh, I'd have to change my color when I do that. Add 4 in here. And then I -4 out here. But here is another tip and trick. How many sets of this do I have? I have 3 of them, right? That 3 out front means something. So did I add 4? I added 12, right? Because of that 3. If I multiply that 3 through, I really just added 12. So this means I got to take away 12. Oh, all of a sudden this just got another step, and I don't know what I'm doing. So if you have a coefficient here, you have to multiply what you're subtracting by that same coefficient. And do it slow. Like when you're starting this, like take the time, watch your steps, write them all up, like take it slow. Because you will drive yourself insane trying to do it quickly. Okay, so my 3 C's out front. I'm going to factor my trinomial. What are the factors? A positive 4 that will add up to a negative 4. Negative 2, negative 2. So can I do this? Right? Because they're both the same, negative 2 and negative 2. Do you want me to write it out? Are you sure? You can say yeah. Okay. And now I'm going to simplify what's outside. So I have 16 minus 12 plus 4, and I am in vertex form. Okay. Does anybody recognize a connection, or does anybody see a connection? Does anybody want to see a connection between your side note and your vertex form? Done two so far. Anybody see a connection? Yeah, which connection? I think I know where you're going. The quotient, where does it show up? The x coordinate of your vertex. That's the tip and trick. Because this will come in handy when you have terrible numbers that you're dealing with. So the quotient, it's not the squared, but the actual quotient is the x coordinate of the vertex. Okay, I'm making a connection for you now because this will help you when you're doing 7/15 later. Because nobody wants to factor something with a 7/15 somewhere in here. Nobody wants to factor that, right? Nobody wants to do that. I mean, maybe you do, but I definitely don't. All right. Step 1, group my x's. What's step 2? Take out that coefficient, right? Common coefficient. Sometimes it's not going to look very common, but it's got to come out. So the negative 4 is going to come out. I'm left with x squared plus 3x. I'm going to leave some space in my brackets. And then plus 5. Okay, so things that can really screw you up, that will change where your vertex is, and will make you cry, especially if I ask you to graph these. When you take out your negative 4, that would change to a positive. That's going to affect things later. Okay, now what am I going to do? Side note. Ugly. So we got 3 divided by 2 squared. Anybody need to yet? Already. It's okay. It's okay to say that it's not your favorite thing. So that means I'm going to add a 9/4 here, and I'm going to minus a 9/4, but it's going to be multiplied by a negative 4. Okay. All right. Orange and red, probably pretty terrible. All right, so I'm going to jump to the one just above it for a second so we can model it. Now this one was nice and easy. This one was nice and easy to factor. That was when we were young, full of them and vigor. Days of easy gone by. We're past that now. So what we noticed is that the quotient was your x coordinate. I'm not going to expect you to factor this unless you got lots of time on your hands. I have no desire to do that. So what I'm going to ask you to do is jump right to your vertex form. What's my quotient? 3/2. Is it positive or negative? And then I simplify step over here. Plus 5, which is 14. Ooh, did you guys see that math happening there? It's like, that was magic. I don't know what you did. Okay, so, what I did in my head is I said 4 goes into -4 how many times? Hopefully, 4 goes into 4 times? 1 time. 1 time. Right? That, so these would cancel each other out, leaving you with a minus sign, so -1 times -9 is 9, 5 times 9. You could have done +5 minus 9 times -4 over +4, so it'd be +5 minus a -36 over 4. 36 divided by 4 is a -9. Subtract a -9, they're going to be added together. That's where you get the 14. I don't like doing this because it's sometimes I get really ugly numbers. So if I can divide these out first to get smaller numbers, any chance I can not to pick up my calculator, I really try to do those little things so that I don't have to. If I can get smaller numbers, I like to do that. So we're on vertex form. Hey, where's our vertex on this? Right. Which is? Give it to me as a decimal. 1.5. So our vertex would be at -1.5, +14. How many x-intercepts do I have? How many x-intercepts do I have? I'm not looking for where, I'm just looking for how many. You sure? Yes. Are you sure? You're correct. Because if I graph this, -1.5 is this way, 14 is up here, opens down. It was the y. So these are the visualizing things. So, okay, all right, we got this. So then you see what happens when we have ugly numbers. We jump right to just the vertex form without actually doing the work of factoring. Please don't tell my grade 10. Okay. Everybody's starting with this one, so I just want you to feel emotionally prepared. I'm sure you guys will surprise me. So step 1 is group by axis. What's step 2? I'm going to take out the -1/2 because I always need to have a coefficient of 1 of the x squared. It's 8. What kind of 8? Negative 8. You guys are like, you're crazy. He's right, it is a -8. And there was nothing on the other side, so what would that? So this would be 0. Ah, okay, good. I'm glad somebody asked that question. Let's do a little math up here. So when we factor something else, so let's say I have 2x squared plus 4x. We'll just leave it like that. When I common factor that 2, what do you're kind of dividing out that 2, right? You guys would agree with me? Yeah? So the 2 would go outside, I have x squared plus 2x. So everybody comfortable with that? We're not subtracting, we're dividing it. Okay? Yeah. All right. I love it. So what we're doing is we're taking 4 and we are dividing it by a -1/2. You guys would agree with me? You just told me that when we did it simpler, so we're just going to apply something more complex. The rules of math never change. They really don't. So this is like saying 4 divided by a -1/2. Do you divide by fractions? Multiply by the reciprocal.
Are you taking on to the denominator goes to the numerator?
That's what reciprocal means.
Yeah.
It means to flip it. Yeah. So that's how I got the 8. And when you think about it, if I go forward, a -1/2 times by a -8 should give us that +4. Anytime you're dividing by a decimal, you're actually going to get a bigger number. And it doesn't seem intuitive because dividing, we've always taught, like, breaks it down into smaller groups. Like, if you divide, like, if I divide the class in half, if we have 24 of us in here, I'm going to have groups of 12, right? So the number's smaller. But when you're dividing by a decimal, they get bigger. How many halves of people do I have? So if I have 24 people, how many halves are there in this room? 48, right? Because each one of you makes up 2 halves. Okay. All right. So back to this. A side note. My side note. So I'm going to take -8 divided by 2, square it. -4 squared is a +16. So +16 minus 16. What do I get to do to that -16? -1/2. And so we are at -1/2. X, now if I were to factor this, x minus 4 squared, don't forget the squared, because if you lose the squared, then we're in a linear situation, and then we're back to 10, and we've already done that. And this would be a +8. So where's my first x? +4, +8. How many x-intercepts? Sure. Perfect. So you have 2. Okay, we got the hang of this stuff? Okay, good times, good times. All right, I'm done. We're going to do this last one.